Okay, so in this video we are going to have a look at a long question, a section B question for logs and indices. So this one is worth 50 marks. So they tell us its magnitude of an earthquake is measured on the log scale, that's fine. It's called the Richter scale. So intensity I, which is measured in millimeters, and they give us a formula here, or a function for the magnitude. They tell us IO is threshold quake intensity, that's fine, but has an amplitude of 1 micron, and then here the important part, they tell us 1 micron is 10 to the power minus 3 millimeters. Now part A asks us to calculate the magnitude of an earthquake with intensity 500 millimeters, so I will equal 500, and the answer correct to 1 decimal place. Okay, first thing we'll do is write our formula. So that's log to the base 10 of I over, and we know what they told us, I0 is 10 to the power minus 3. So in part A we're told the intensity is 500, and we're just going to substitute in now. So that's log to the base 10 of 500 over 10 to the power minus 3 into our calculator. Log to the base 10, 500 over 10 to the power minus 3. We get 5.6989 70004. So to answer their question, or the magnitude 1 decimal place would be 5.7. And that's part A answered for 10 marks. Part B, a new earthquake in San Francisco. They tell us it measures 8.25. Calculate the intensity and correct 2 decimal places. Again, we write out our formula. M is equal to log to the base 10 of I over 10 to the power minus 3. M is equal to 8.25. So we get 8.25 equals log to the base 10 of I over 10 to the power minus 3. We're a little bit stuck here in terms of logs. We can't put it into our calculator. So we're going to come out of logs and into indice notation. 10 to the power of 8.25 will equal I over 10 to the power minus 3. I'm going to cross multiply by 10 to the power minus 3. So we get I is equal to, into your calculator, 10 to the power of 8.25 multiplied by 10 to the power minus 3. Give you 177,827.941, and we were asked for 2 decimal places. So the intensity will equal 177,827.94 millimeters. We were told at the start of the question that I was measured in millimeters. You'll lose a mark if you forget your unit of measurement, so always keep an eye on that. Okay, part 2 now, another new earthquake in Australia. They tell us it measured 5.6. And the question here, how many times more intense was the one in Newcastle? Okay, so formula again. And they tell us it measures, we'll put an N here for Newcastle, 5.6. So we get 5.6 equals log to the base 10 of I over 10 to the power minus 3. Like the question above, we need to use indice notation. We're going to cross multiply by 10 to the power minus 3. Into our calculators, 10 to the power of 5.6 multiplied by 10 to the power minus 3 will give me 398.1071706. And we had figured out earlier that the intensity of San Francisco was equal to 177 827.94. So we're going to divide Newcastle into San Francisco to see what the difference is. So we have 177,827.94 divided by 398.1071 706 into our calculators. And we get 446.6835896. We've been asked for two significant figures, so that will be 450 times more intense. Okay, and that's B part 2 answered for 10 marks. Part C now, we have another earthquake in Chile. They tell us it's approximately 18 times more intense than San Francisco. They want to know what did it measure, correct to 1 decimal place. So San Francisco, we had the intensity was 177,827.94. We're going to multiply that by 18. And we get quite a large number. Okay, and they're asking what does it measure on the scale, so write down our formula. So that's log to the base 10 I over 10 to the power minus 3. And we know that I is equal to 902.92 into our formula. And into our calculators, so that's log to the base 10 of 32. Let's set up our fraction 320,902.92 all over 10 to the power minus 3. 9.505 2725.03. So our magnitude for 1 decimal place would be 9.5. Okay, and that's part C for 5 marks. Part D now. They tell us heavy goods lorry running on a road can cause a microquake rating up to 3.3 on the Richter scale. That's fine. At home seismograph records an intensity of 40,000 times I to the power of 0. And they're wondering what occurred. Was it an earthquake or a heavy goods lorry driving by? So just need to convert this first. We know from above that I0 is 10 to the power minus 3. Into our calculator. And we get 40. Okay, and now our formula. So we have log to the base 10 and again straight into your calculator. Log to the base 10 40 over 10 to the power minus 3 will give us back 4.602 05991. Okay, so we'll just leave it at 1 decimal place. Now they tell us for a lorry the magnitude is less than or equal to 3.3 and 4.6 is greater than 3.3. So our statement, it is more likely than an earthquake. Let me just justify our workings here as the magnitude was 4.6, which is greater than the maximum microquake. Magnitude caused by lorries. And that's D part 1 answered for 5 marks. And the last part of the question, we have what was the maximum amplitude of the reading to suggest that it was caused by a lorry. Answer correct to the nearest millimeter. Okay, so for this one here we have our formula again. Log to the base 10 of I over 10 to the power minus 3. And they tell us the maximum for a lorry will be 3.3. Okay, so like we saw earlier on in this question, we're kind of stuck here in terms of the log notation. So we're going to convert to indices. So we get 10 to the power of 3.3 equals I over 10 to the power minus 3. Cross multiply by 10 to the power minus 3. So that's 10 to the power 3.3 multiplied by 10 to the power minus 3 will give me 1.995262315. And they had asked for answer correct to the nearest millimeter. We know I is measured in millimeters. So the maximum amplitude 1.99 will round up to 2. So 2 millimeters. And that's D part 2 answered for 10 marks. And that's our whole 50 marker question done for logs and indices.